In this screencast, I'm going to look at vectors in the idea of vector addition, subtraction, and multiplication by a scalar. Okay, so we've seen previously a vector, just an object in space with magnitude and direction. So here I've got a vector A, and I'm going to define another vector B. I'm going to have vector B looking like this. Okay, so I've got two vectors, A and B, and if I want to add these two vectors together, what I do is A add B is I place the start of the second vector at the end of the first vector. Okay, so A add B, so I go up vector A till I get to the end of it, then I place the start of B at the end of A, and B extends out to here. Okay, so this is a geometrical representation of what's happening. So if I look at the total vector, I'm starting off A, and I'm going to the end of B here. So this vector in yellow is simply A plus B. Okay, so how is vector addition defined? Well, if I have my vectors in general sense, A is a vector in three-dimensional space with A1, A2, and A3. And similarly for B, B equals B1, B2, and B3. Okay, so simple. It's very, very simple to add two vectors together. You just add the corresponding elements. So I have A1 plus B1 is the first value, A2 plus B2 the second, and A3 plus B3 in the third. Okay, so that's the definition of vector addition. Let's do an example of that. Okay, just going to scroll up a bit. Okay, so here we're going to look at one or two examples. So for example 1, I'm going to have A is equal to my old friend 1, 2, and 3, and B I'm just going to make up some values. Okay, so two vectors A and B. The addition of these two vectors, the first number will be 1 plus 1, the second will be 2 minus 2, because when we add a negative number, it's effectively subtracting it, and the third is 3 add 0. And if we just evaluate these, so 1 plus 1 is 2, 2 minus 2 is 0, and 3 plus 0 is 3. Okay, so that's the vector A plus B. Well, that's vector addition. What about vector subtraction? Okay, so if I want to try and recreate my two vectors as I had them before, so A was something like this, and B was like a horizontal line. Okay, if I want A minus B, well, when we minus, we reverse the direction of the vector. So if A goes up here, now plus B would be going up there somewhere. That's A and that's B. But minus B reverses the direction. And so in this case, B would be going from right to left here. Okay, so if I just change my pen colour, so A minus B will be this vector here. Okay, so when you minus a vector, you're effectively reversing its direction. Okay, and vector subtraction is defined in a very similar way to vector addition. So if I have vector A is A1, A2, and A3, and my vector B is B1, B2, and B3. Okay, so A minus B, and you've probably guessed it already, is A1 minus B1, A2 minus B2, and A3 minus B3. Okay, and I'll just quickly go through an example of that. Okay, just scroll up a bit. So, second example of this screencast. Okay, so I can't quite remember what my vector B was from earlier, so I'm just going to make up some numbers. Okay, so if these are two vectors defined, A minus B will be 1 minus 2, so it's 1 plus 2, 2 minus 1, and 3 minus 3. So 1 plus 2 is 3, 2 minus 1 is 1, 3 minus 3 is 0. Okay, so vector addition and vector subtraction, very, very simple. Okay, the last thing I'm going to look at in this video is the idea of multiplication by a scalar. So if we go back to our old friend vector A, okay, there's my vector A. Now multiplication by a scalar scales my vector A. So you can see it's pointing to the right and upwards. But if I was to multiply that by 2, what I'd left over with, what I have, is a vector which is twice the magnitude of vector A, but pointing in the same direction. Okay, so if I have, let's say k is my scalar, so k is a number times by a vector A. Okay, so that's k times A1, A2, and A3. That's the same as saying k times A1, not plus, that's the first one, k times A2 in the second number or value, and k times A3 in the third. Okay, so get it? Okay. Anyway, that's a terrible joke. So if have a look at a third example, if I got a vector A which is equal to 1, 2, and 3, and let's say I've got scalar k which is equal to 4. So what happens when I multiply A by my scalar k? We have 4 times A, which is 1 times 4, the first value, 2 times 4 in the second value, and 3 times 4 in the third. And just a quick bit of arithmetic. And 3 times 4 is 12. Yep. Okay, so that's scalar multiplication. And one final thing to note is if you multiply by a negative scalar, what that does is simply reverses the direction of A. So if I could redraw A, that's my vector A. If I multiply A by -1, just reverses the direction. Okay, so if I have a look at an example, example 4, if A is my vector 1, 2, and 3, and let's say my scalar k is -1, then k times A equals minus the vector A, and so all we do is we multiply each of the elements by -1. Okay, so hopefully you're happy with addition, subtraction of vectors.